This is 1.5.3b. It's probably one of the questions that I get the most often. What happens is you draw a first card and you figure out whether or not it's hearts. And then you draw a second card and figure out whether or not it is a picture. So let's just make a note of that for ourselves, because we're dealing with first card is hearts or not, and the second card is a picture card or not. And we want to see whether or not, like, the first card being a hearts and the second card being a picture would be independent or not. So I'm going to do a tree diagram to actually prove that these are independent. But what I have to do here is I actually have to make it look a little more complicated. So for my first card, it's either hearts or not hearts. Okay, so hearts or not hearts. And then for our second card, we want to see if it's picture or not. But to actually find these probabilities, I have to break my first into 4 categories, because there are 4 possible categories we'd be interested in. Hearts and picture, hearts and not picture, not hearts and picture, or not hearts and not picture. Those are 4 different possible outcomes for the first card. And let's find those probabilities. So for a heart and picture, of our pictures, we have a jack, queen, and king that we picture cards. That is 3 out of our entire deck of 52. Hearts and not picture would be the other 10 cards in the suit. Not hearts and picture cards would be, I think, 9 out of 52, because there are queen, jack, queen, and king in 3 different suits, so 9. And not hearts and not picture should be 30 out of 52. Let's just add that up to make sure I did it all. Yeah, so again, if you just look at what's in your card, in your deck of cards, count for everything that's hearts and picture, there are 3 of them. Or hearts and not picture, there are 10 of them, etc. Okay, now for our second card, this is where you have to think about a little bit. So if your first card was a hearts and a picture, what's the chance of getting a picture card? Now this is where it gets a little bit confusing. So at this point, we don't really care whether or not our first one was hearts, we just care whether or not the first one was a picture card. So if we took out 1 picture card, then that means there are, let's see, there are 3 picture cards per suit, which means 12 picture cards total. So we used 1 picture card, so there are only 11 picture cards out of a total of 51 cards. For not picture cards, if there are 12 picture total, that means there are 40 not picture. So we'd have 40 out of 51 not picture cards, because we got a picture card first. But if we did a not picture card, we still have 12 picture cards. We'd only have 39 not picture cards. Okay, and again down here, we don't really care that it was a heart or not, we only care that it was a picture card. So we used 1 picture card, so there's only 11 out of 51. And for not picture card, we used the picture, so there are still 40 out of 51 not picture cards. And again, if we did a not picture first, then there are 12 out of 51 picture cards and 39 out of 51 not picture cards. Now what I can do is I can go through and multiply all these to find the probability of the intersections. So for my intersections, I'm going to multiply across. So 3 times 52, or 3 out of 52 times 11 out of 51 gives me 0.01268. So I'm going to go through and do this for every branch, which does take a while since this is long. And I can keep going to find all these probabilities. But I don't need to keep finding more. I can stop here and figure this out. So to see if they're independent, I want to know, does giving a heart first change the probability of getting a picture card? So the overall probability of a picture card, we know that there are 12 picture cards out of 52 in my deck, which 12 divided by 52 is 0.2307. Now let's find the probability of a picture card if you got a heart first. So to do that, let's go up and see which probabilities have a picture card if I got a heart first. So having a heart first means that I have to be in this top half. So let's see which ones have a picture card. So this one has a heart and a picture card. And this one has a heart and a picture card. So let's add those together. So 0.01244 plus 0.0452 . So that's what I put on top. That's the probability of the intersection. Now divide by the probability of hearts. Let's see, probability of hearts is 1/4. Sorry, I had to stop and think about that. Which gives me 0.2306. Notice the difference between this and this is just rounding. So these are equal. So the probability of picture card overall is 0.2037. The probability of picture card, if you know the first one's hearts, is still 0.2306. So either way, it doesn't matter if you got a heart first or not. This probability of getting a picture card is the same.